Millions of people require emotional support, but professional care networks are constrained by physical limits on time and resources. When you combine those logistical walls with the heavy friction of social stigma and regional language barriers, reaching out becomes nearly impossible for a massive segment of the population. Because accessing care requires navigating this high-friction environment, a severe dead zone forms. People express distress, but the earliest, most subtle warning signals, shifts in tone, signs of withdrawal, and language masking, they vanish into this vacuum entirely unnoticed. The core of this crisis is a technological one. Our existing communication networks lack the sensitivity to detect these distress signals at the scale they actually occur. The software industry's initial response to this bottleneck was the basic monolithic AI chatbot. Asking a single algorithm to act as an empathetic listener, an accurate risk assessor, and an emergency dispatcher simultaneously creates immediate technical failure. When overloaded with these competing inputs in high-stakes environments, standard bots break down or generate dangerous advice. Human distress operates with infinite overlapping complexities. Managing that level of nuance safely requires highly compartmentalized, specialized precision. Hope AI addresses this by using Agentic AI. This architecture utilizes a coordinated ecosystem of 12 highly specialized artificial intelligence modules working in tandem. The AI orchestrator functions as a central routing hub. It analyzes incoming interactions and instantly directs specific tasks to the correct specialist agent based on the immediate context. By dividing the computational and cognitive labor among specialists, this architecture manages the volatile variations in human emotion without the system breaking under the load. Let's track an interaction in real time. A user is walking home at night, speaking into a low-bandwidth voice interface in Telugu. During ingestion, the voice AI and multilingual agents transcribe the audio. They evaluate phrasing and cultural context to extract the emotional nuance of the user's voice, rather than settling for a literal translation. The orchestrator receives the data and splits it into two simultaneous pathways. First, the AI companion constructs a safe reply using retrieval-augmented generation, pulling from a secure medical database. Simultaneously, emotion and risk signal agents scan the text for hidden markers of distress. Conversing empathetically while simultaneously conducting deep risk analysis in the background is the exact breaking point for standard chatbots. Here, the two tasks are processed cleanly in milliseconds. During this analysis, the risk signal agent detects a high-risk indicator buried in the user's interaction. The AI safety agent immediately intervenes, halting the system's ability to offer autonomous medical advice or conversational platitudes. With the conversational flow locked down, the system pivots. The crisis intervention agent takes over and triggers a predefined human escalation workflow. Hope AI maintains clinical safety by recognizing its own algorithmic limitations. It is engineered strictly for intelligent triage and coordination, never for medical diagnosis. The digital escalation now crosses over into the physical world as the crisis agent alerts the volunteer coordination network and the doctor AI assistant. This dashboard bypasses the dangerous cold start problem, where responders enter a crisis blind. It provides the incoming doctor with a structured timeline, synthesized case intelligence, and explicit color-coded risk markers. Armed with this real-time contextual data, a trained professional steps into the loop, fully briefed and instantly prepared to act. The platform's primary function is to equip human professionals with precise, actionable context the second they enter a crisis. To advance its technology readiness level, Hope AI is transitioning from a validated prototype into a large-scale field pilot across Telangana. This deployment functions on a strict division of labor. Cyberhelps engineers the digital architecture and cybersecurity, while the Cyberhope Foundation powers the implementation, coordinating the physical network of NGOs and doctors. This scalable digital infrastructure ensures that human empathy is deployed exactly when and exactly where it is needed most.